Hi, my name is Ethan Hoover, and this is my presentation on heat loss in different thermoses for the ME308 Instrumentation and Measurement class. The goal of the experiment was to see how different thermoses of different size and material would hold the heat of water over the course of a 3-minute trial. A kettle was used to boil the water. The temperature of the water in the container was measured every half second using a surface temperature sensor connected to a LabQuest 2 device using Logger Pro on a laptop to graph the data. 1.5 cups of boiling water was used, equivalent to 12 ounces. 3 thermoses were used in the experiment, one of 18 ounces, one of 24 ounces, and another of 18 ounces, 2 of which were Yeti branded, the 24 ounce and 18 ounce, while the other was a aluminum shelled off-brand container. I believe the different material used in each container, such as the size, lid seal, and insulation configuration, such as double wall or single wall, would affect the results of the experiment. This slide shows the differences in each thermos. The 2 main thermoses, as said previously, being 18 ounces and a larger version of a Yeti being 24 ounces. Each thermos in this experiment was filled with the same amount of water, 1.5 cups. That means the 18-ounce container was 67% full, while the larger thermos was 50% full. On the left is a picture of the water heater used, and on the right is the data collection setup. The temperature over time for each thermos is shown in the figures on the right, with a linear trend line being applied to the bottom graph that gives a rough outline of the rate at which each thermos lost heat versus their initial standing when the sensor was put into the water and the trial had begun. On the left is the slope rates, the large thermos having a slightly less loss in Celsius per second. The otter tumbler is the higher of the 3 trials, as the starting temp was slightly higher than that of the Yeti thermoses. Results in discussion. The large thermos held temperature slightly longer, with a 0.642 Celsius loss per minute versus a 0.708 Celsius loss from the other 2. Both small thermoses lost heat at the same rate. I did not think this would happen, but it did. Percent water vapor. Boiling water in a closed container with a mixture of air, as is in all 3 thermos cases, would have resulted in a liquid vapor mixture of water where temperature is the independent variable. I predicted that the smaller containers would keep their heat longer as the amount of air to water ratio would be smaller, therefore less room temp air would be mixing with the boiling water, resulting in an equilibrium temperature and cooling the water down faster. This apparently didn't play out, as the large Yeti thermos held its heat better than the other 2 containers, if though marginally. Sources of error. Measuring out the boiling water in regular measuring cups was not done perfectly, and due to the time constraints, I wanted to get the water into the thermoses to begin the experiments as soon as possible, which meant there was very small differences when using the measuring cups and the amount of water poured into each thermos per trial. Pouring the water into the thermoses meant there was some spilling as well, which I believe would have slightly affected the results. I believe the higher the water temperature when the experiment started would have also affected the trials, such as if I waited too long to put the water into the thermos to begin the trial, or if the water was hotter from being boiled longer. The hotter the air in the thermos would also be a leading source of error. For the first 2 tests, the water temperature was fairly similar, within a degree Celsius, even a half degree, but the other thermos was 2 degrees higher initially, being about 90 degrees Celsius. There is a range of error being around 0.01 Celsius for the surface temp sensor used in the experiment, and the last source of error was the quality of the sealing around the top of each thermos. The surface temp sensor was fed from the side of each lid into each thermos as shown in the setup previously. Therefore, the gap that sealed each thermos was slightly different in size, which could mean that more heat was able to escape each thermos. If I were to repeat the experiment again, I would do more trials per thermos and find a better method for sealing the lids. The 24-ounce thermos, despite what I predicted, performed best. It lost 0.066 Celsius per minute compared to the other thermoses. The similarities and differences in the material used didn't affect the outcome, and I believe that's due to the ineffective lid seal that was created by having the lid cracked at an angle. Thank you for listening to my presentation.